Hello 108 students, welcome to chapter 7. We are going to work with rational expressions, and section 7.1 is going to give us a basic definition of what rational expressions are, and of course we're going to tackle the very first page. Okay, now we're going to say this phrase a lot here in this chapter, and I want to get everybody on the right page with relative to what a rational expression is. Now, just to help you out, for me, my acronyms in engineering days, RE stands for rational expressions. If I say an RE, that's just me taking a shorthand notation of that. Now, a rational expression, when I first started teaching this, it was like, how do I get this across to students? And one day it finally dawned on me. What's the basic definition of a rational number? Rational numbers are numbers that make sense, and that means it's a number that's in a form of a fraction. Now, A divided by B is no more than different than 6 divided by 2, which would equal 3. Okay, so can I take 3 over 1 and write it as a rational number? Yes, 6 divided by 2. And with a rational number, that basic idea, when you see in the book here, there says a rational expression is the quotient, which means division, which means a fraction bar, of two polynomials. Okay, it's a polynomial divided by another polynomial. Okay, and so a couple examples of these are 4 divided by x. Notice here that you have got you have division where you've got the variable is allowed to be in the denominator. That's the big new thing you're going to see here. It can also still be up at the top, x to the 5th, which you're used to seeing it as x to the 5th divided by 1. That's in a form of a rational expression. Okay. Big thing you're going to notice, like I just said here, is you're going to see the variable down the denominator. Okay. So objective number 2 wants us to get comfortable with function notation here. A rational function, now that you know, is two polynomials that have division, or a quotient of two polynomials, is nothing more than a polynomial p of x, it doesn't matter, that's just a notation, divided by another polynomial. And relative to one specific variable x, f of x could be represented by that division. Okay, and so we could look at some examples here, example 1a, but before we do, I need to pause for a second here. We need to cover something pretty important. Are you allowed to divide by 0? And so if I say 6 divided by 0, are you allowed to do that? Hopefully everybody remembers it's undefined. And remember, the shortcut was when the 0 is under the line, it's undefined. Okay, you're not allowed to divide by 0, and that's simply because it doesn't exist. Okay, you cannot come up with 6 divided by 0 and give me an answer. If you say 0 times 0 is 0, it does not equal the quotient. When I come up here and say 6 divided by 2 equals 3, I can take 3 is the quotient divided by the denominator. 3 times 2 equals the numerator. Okay, that always works. Okay, here you cannot come with it. You can't come up with any number multiplied by 0 to come up with 6. So therefore it's undefined. It simply doesn't exist. Therefore you have to be cautious throughout this chapter to make sure that you check for restrictions. Restrictions are what I like to use the letter capital R, is what x is not, or the variable is not allowed to equal to. Then the divisor, in the denominator, q of x, you cannot have that equal, that expression cannot be 0. Okay, so a couple warm-up exercises here to focus on. Example 1a, here's a function, f of x. Now they say 3 divided by 7x minus 4. Is this a rational expression? The answer is yes. You have division because of the fraction bar, and you've also got the variable down in the denominator. Okay, they want to know what are the restrictions. Okay, now the idea here is you take whatever's in the denominator, 7x minus 14, and you set it equal to 0. Now, teaching this over the last couple years, I get students, they get confused. You solve for this, and then they go, then I turn around and say x does not equal 0. The way I like to teach this now is, like to see me change your notes here on this, is take the denominator and say this denominator, this expression cannot equal 0. Solve for that value. So I added 14 to both sides. 7x cannot equal 14. Divide by 7. And finally, x cannot equal 2. I think that's a little easier way to grasp the concept. So take the denominator, say that cannot equal 0, and find what value makes that true. And that's all you have to do for those. Now you look at number 1b, and you might say, hey, they just want to know the restriction. That's all you're working on. So you take this denominator, x squared minus 4x plus 3, and set it that expression cannot equal 0. Sorry, it's easy to put these in here. Set the denominator so it's not equal 0. What value is the restriction? X cannot equal what? Okay, now you've got a trinomial. Go ahead and do your factoring. Okay, you guys are pretty comfortable with that one. That's a pretty easy example here. And take each of the parentheses. Remember what value our zero factor property tells you. Take the parentheses, set them not equal to 0. Let me keep putting these in here. Find out that x cannot equal 3 and x cannot equal 1. Why? Because if you put a 3 in here, you will get a value of 0. If you put a 1 in here, 1 squared minus 4, 1 plus 3 will all equal 0, and you can't have that. Okay, so that's the idea here. Looking at objective 3, they want you to grasp the fundamental concept that if you have a general fraction and you multiply by a number, so if I take 6 divided by 2, and if I say and I multiply by something equivalent like 3 over 3, you're going to get 18 over 6, which is going to equal 3, and 6 divided by 2 does equal 3. Okay, so they're trying to get you to understand this concept of when anything divided by itself equals 1, and therefore you can cross it out because it equals 1, and you're doing multiplication, and you're left with that original rational expression. Okay, you're going to see lots of examples on that. So this is the fundamental property of rational expressions. Anything divided by itself equals 1, and that's what I want you to see and remember. Okay, Mr. Q here, we're going to sign off here on page 1. So when I see you on the next video, we'll keep moving and take care of page 2. Okay, take care. I'll see you then. Bye.